Hey YouTube, so in this video I want to talk about modality and possible worlds. The way that analytic philosophers in particular tend to think about modality is in terms of possible worlds. So they might say that the modal facts are grounded in facts about possible worlds. So if I say it is possible that P, this will be true just in case at some possible world P is the case. So it is possible that there are blue swans because at some world W there are blue swans. Or it is necessary that P, well, that's going to be true just in case at all worlds P is the case. It is necessary that 1 plus 1 equals 2 because at every possible world 1 plus 1 equals 2. So modality turns into quantification over worlds. And this is, a useful way of thinking about claims about possibility and necessity, and also other modal claims. So if I make, a counterfactual claim, if I say, if P had been the case, then Q would have been the case, we can understand this in terms of, so what we would say is, well, that's true just in case at the closest possible world in which P is true, Q is true as well. That's the standard semantics for counterfactuals. So if I had dropped the glass, it would have broken. Well, that's true because in the closest possible world in which I do drop the glass in fact breaks. So you sort of imagine, imagine the world exactly the same as it actually was, up to the point where I'm carrying the glass, and then modify it, tweak it slightly so that I drop the glass, and then what happens? Well, the glass breaks. So in the closest possible world in which I drop the glass breaks, and that's what makes it true that if I had dropped the glass would have broken. Okay, so modality is often understood by philosophers in terms of these claims about possible worlds. I think, if we're just sort of proposing possible world semantics as a tool for the model theory of modal logic or whatever, that's perfectly fine, right? Like by talking of possible worlds and then specifying particular accessibility relations over worlds, we can give a useful semantics for modal for inferences, right? Like inferences in modal logic. It's quite another thing to claim that this is what modality is metaphysically. And, well, I'm going to raise some objections to that. Okay, so the first problem that I see with this way of understanding modality is irrelevance. This is a point that was raised by Kripke, I think, against specifically David Lewis's view of possible worlds. So there are different ways of understanding what these possible worlds are supposed to be. According to David Lewis, possible worlds really exist in just the same way the actual world exists. They are concretely existing entities, just like the actual world. Now, Kripke raises this objection that, well, it just sort of seems irrelevant to modal claims about this world. So if you take the claim, Humphrey might have won the election, well, this says something about what might have happened to Humphrey. It doesn't seem to say anything about what did happen to one of Humphrey's counterparts in another possible world. Like when I say Humphrey might have won the election, I'm talking about Humphrey. I'm not talking about some guy in some other possible world. So it seems like the facts about what goes on in some other possible world just aren't the right type of facts to make true fact claims about what might have happened in this world. That's basically the issue Kripke raises. You can think of this maybe as a kind of like modal open question argument, analogous to the moral open question argument that's famous in metaethics. So the modal open question argument would be, well, look, if I say, like, I can say, yes, it's true that my counterpart in some other possible world does X, but is it really possible for me to do X? Was it really possible that I did X? Like, yes, it's true. My counterpart in some other possible world won the election, but does that mean that it was? Why would that make it possible for me to have won the election? Or I can say, yes, it's true that something is the case in every possible world, right? But does that does that make it true that it must necessarily be the case? So those seem to be open questions. Now, as I said, Kripke presented this as an objection to David Lewis's version of modal realism. But it seems to me that this same issue is going to arise regardless of how we conceive of the possible worlds. So you can think of possible worlds as being these things that exist concretely, like really exist in the same way the actual world exists, or you can think of them as just being, abstract objects of some sort. Maybe they're sets of propositions. So another way to think of possible worlds is that they are maximal consistent sets of propositions or something like that. So for the abstractionist, we would say, well, okay, so when I say Humphrey might have won the election, what's going on there is that there is some abstract representation of Humphrey winning the election. So there's like some set of propositions which describe Humphrey winning the election, some maximal consistent set of propositions that describe Humphrey winning the election. Okay, so what? What does that have to do with Humphrey? Like, that just seems to be a completely separate thing. The general issue is how can it be the case that what happens over there, whether over there means in some other concrete world or in some set of propositions or whatever, how can it be the case that what happens over there makes it true about what could or what must happen here? This is the general. That's the general worry, and it seems to be the case that that's going to arise on many different ways of conceiving of possible worlds. They just don't seem to be the right kind of thing that could ground modal facts. I guess there's a sort of related issue here, which is a kind of epistemic access problem. So this is a problem for a lot of Platonisms in general. Like if I'm a Platonist about mathematics, if I think that mathematical claims are made true by some realm of abstract objects, like numbers really exist, they are abstract objects, they really have the sort of properties and relations described by mathematical theories. Well, the problem that arises here is how do we have any access to that? Abstract objects are non-spatial, non-causal, I can't interact with them, so then how could I know anything about them? We get the same problem in the case of possible worlds. Whether we conceive of possible worlds as being concrete entities or as being abstract entities, it looks like there's no way for us to interact with them. But I think in the case of possible worlds, there's like the problem is kind of more serious, because when you take numbers, for instance, what you can at least say is that there's like a fairly obvious sense in which, at least from the Platonist point of view, these abstract objects are the content of my thoughts. Like when I think or say claims about mathematics, my thoughts are directed towards these abstract objects in some immediate way. Like when I think 1 + 1 = 2, I have like 1, the number 1 is part of the content of my thought. The number 2 is part of the content of my thought. And there is a problem of epistemic access here. There's a question of like, well, okay, how the hell do I interact with this abstract thing? But still, it's the abstract thing is like the thing that my thought is directed at. But when it comes to modality and possible worlds, it's not really so obvious like what it is that my thought is directed at. So I say, for instance, that I could have worn a blue shirt, right? Right now I'm wearing a yellow shirt, but I could have worn a blue shirt. Okay, that's a modal claim. And this is supposed to be, grounded in facts about possible worlds. Well, when I say I could have worn a blue shirt, I'm thinking first and foremost about myself and my shirt. Like, how do I know I could have worn a blue shirt? Well, because there are blue shirts in my wardrobe, because I have worn blue shirts in the past, because people like me wear blue shirts. I mean, I'm thinking about actual people, actual things. Again, it doesn't seem to be the case that I'm thinking about these alternative possible worlds. So usually with Platonism, there's this epistemic access problem of like, how do we bridge the gap between the thought and the thing that the thought is supposed to be about? Like, how do I bridge the gap between, my thoughts about mathematics and then this abstract realm of numbers or other mathematical objects? But when it comes to modality, or at least if we're thinking of these modal claims as really being claims about possible worlds, it's not really clear where the gap is in the first place, right? So like there is a gap. There's still this epistemic gap. There's still this problem of epistemic access. But it's like it's not even clear where that gap is, because when I say like, well, yeah, I could have worn a blue shirt. Again, that just seems to be a thought about myself, not a thought about some counterpart in some other possible world. And if you ask me how I know that I could have worn a blue shirt, again, I'm just going to cite facts about the actual world. Whereas if you say, like, well, how do you know that 1 + 1 = 2? Well, maybe that's a simple... yeah, that might just be self-evident. But generally, like, if you say, well, how do you know this mathematical claim? You're usually going to just cite other facts about mathematics. So, okay, that's one general issue, right? Like this question of, okay, what is even the relevance of these other worlds, right? Metaphysically, there's another problem, which is to do with the fact that possible worlds are maximal. So, a possible world is supposed to be something that like it is complete, is maximal, it specifies everything. I mean, it's analogous to the actual world, right? The actual world is just everything that is the case. That's, I guess, the idea, right? Like all of the facts, all that there is, that's the actual world. And then a possible world is going to be, just like that, but something different happens. So we can imagine history going differently. We can imagine different things happening. There's going to be a possible world for every way that things could have been different. And each possible world is maximal. It's complete. It's a complete description or a complete state of affairs. Now, of course, we can focus on specific we can focus on specific bits of possible worlds, and we can restrict our analysis to some specific class of possible worlds. So if I say if I had dropped the glass, then it would have shattered, then of course we're only considering those possible worlds in which I dropped the glass. But each of the worlds in that set is maximal and complete. And the problem is that modal claims, it seems to me, just don't have this kind of feature. Like this is just the wrong kind of feature to ground the truth of a lot of our modal claims. This is particularly the case in counterfactual reasoning. So I think that a lot of counterfactual reasoning appeals to kind of like models, where models are not maximal or complete. Okay, so here's an example. This you can find that like lots of cases like this in counterfactual reasoning in science. So this example comes from an article by Peter Tan. It's called Interventions in Counternomic Reasoning. But there are lots of other examples that would illustrate the same point. This is just one example. So he gives the example of a counterfactual claim in science. If water had not had intermolecular hydrogen bonding, then it would have been gaseous at room temperature. Okay, so we think this is true, right? This seems to be a true counterfactual about water. If water had not had intermolecular hydrogen bonding, it would have been gaseous at room temperature. All right, why do we think that? Well, it's because water is one of the group 16 hydrides. Other molecules of the group 16 hydrides are gaseous at room temperature, and in particular, their boiling points have a nearly linear relationship to molecular mass. The reason for this is because they're bonded by van der Waals bonds. Van der Waals bonds are much weaker than hydrogen bonds. So, water is an exception to this relationship, this nearly linear relationship between boiling point and molecular mass, and that's because water has intermolecular hydrogen bonding. It's much stronger. If H2O did not have intermolecular hydrogen bonding, then it would have been bonded by van der Waals bonds only, and in that case it would presumably obey the same relationship that you see with these other group 16 hydrides, in which case its boiling point would be somewhere between minus 80 to minus 70 degrees centigrade. So it would have been gaseous at room temperature. Okay, that's the argument, as it were. Pretty simple. And what we're doing there is we're appealing to kind of, well, our background models of what water is, how water works, right? How water is bonded, etc. But let's say we try to think of this in terms of possible worlds. So again, on the possible worlds analysis, when I say if P had been the case, then Q would have been the case, the standard semantics for that is that counterfactual will be true just in case in the closest possible worlds where P is true, Q is true. So we have to look at the closest possible worlds where water does not have intermolecular hydrogen bonding. And then we say, well, okay, what is it like, right? In the closest possible worlds where water does not have intermolecular hydrogen bonding, then it's gaseous at room temperature. Problem. The problem is, well, wait a minute. What actually is the case in the closest possible world in which water fails to have hydrogen bonding? Remember, possible worlds are complete states of affairs. Now, the issue is that if we were to change things so that water does not have intermolecular hydrogen bonding, we would have to change the laws of physics, presumably, right? Like it would require us to shift around the laws of physics and chemistry and so on. So the laws of physics would be completely different. So now if we're changing the laws of physics, what reason do we have to suppose that the linear relationship among the group 16 hydrides would hold, right? This relationship that we observe among these other molecules that are in the same group as H2O, this relationship is something that arises because of the laws of physics. So if we change the laws of physics so that water no longer has intermolecular hydrogen bonding, it looks like you're probably going to, well, I mean, we don't really know, right? Who knows what would happen? But it looks like we might well end up just changing this relationship among the group 16 molecules. It might well be the case that the simplest changes to the laws required so that water no longer has intermolecular hydrogen bonding would also change things so that this relationship fails to hold, in which case the counterfactual would come out as being false. But actually, I mean, I suppose more plausibly, it would be that it just doesn't seem like there's really any fact of the matter. I mean, if you ask, well, what is it like in the closest possible world in which water fails to have intermolecular hydrogen bonding? Well, we're considering worlds in which the laws of physics are completely different. Like, it's not obvious how we even assess closeness or similarity of worlds in that case. And this is going to be this sort of problem is going to arise in many different cases, because a lot of scientific models will involve, take for instance let's say we take a model of a simple pendulum. The simple pendulum model, it describes the relationship between the length and the period of a pendulum, right? Like, a swinging pendulum, a bob on a cord swinging like that, right? So the simple pendulum model has no friction, no air resistance. The bob is a point mass. The bob is on a massless cord. So there's a whole bunch of idealizations that are made, right, when we give this simple mathematical model, right? And there are more complex models where we remove some of those idealizations. But really, I mean, you're never going to remove every idealization. There's always going to be some idealizations. But anyway, we have this sort of simple pendulum model, which is making a counterfactual claim, right? We're sort of saying, well, if we assume these idealizations, if, there was no friction, if there was no air resistance, if the bob was a point mass, then we would observe this relationship between the length and period of the pendulum. It's a counterfactual claim. But now we're saying, well, okay, that counterfactual claim is understood in terms of the closest possible worlds. So what's it like, right? The possible world where there's no friction, no air resistance, where the bob is a point mass, where the cord is massless. I mean, again, that would require completely changing the laws of physics. Who the hell knows how a pendulum would behave if we completely change the laws of physics. It would be, I think it's just like radically indeterminate. But at the very least, it's nothing like our world, and it doesn't seem like we have any way of telling what things would be like. I suppose the claim I would want to make is this: if there are modal facts, it looks like these sorts of facts that these sorts of claims that we find in science should be among them. So our best scientific theories and models tell us not just how the world is, but how the world could be, how the world must be. Like when we give the model of the simple pendulum, we say, okay, if there were no friction, if there were no air resistance, if the bob were a point mass, etc., then this relationship would fail to hold. We want to say that this is among the modal facts. We want to say that it's among the modal facts that, if water had not had intermolecular hydrogen bonding, it would have been gaseous at room temperature. If we want to say that those are among the modal facts, then it seems to me that possible worlds are just not suitable for grounding such facts. Because these sorts of facts, what we're doing here when we make these counterfactual claims is appealing to models. Models are not maximal states of affairs. Now, what exactly models are is another question. That would be a whole other video, right? Like, what the hell is going on when we appeal to these models? But at the very least, it seems to me that it's not appropriate to think of them as possible worlds. That doesn't strike me as very plausible. So I suppose there's a sort of dilemma, right? Like, we could say on the one hand, like, okay, first one of the dilemma would be to say, yeah, science uncovers the modal facts, but in that case, possible worlds are not sort of suitable for grounding such facts. The other one of the dilemma would just be to take a much more anti-realist view of the sciences, say, okay, well, maybe possible worlds do ground modal facts, but then it just turns out that the vast majority of counterfactual claims and modal claims in the sciences are false. So anyway, those were some thoughts on possible worlds and perhaps some problems for the standard way of thinking about modality. The standard way of thinking about modality as being grounded in possible worlds. Again, none of this is an objection to possible world semantics as a tool for the model theory of modal logics. There's no objection to it there. The objection is specifically to the idea that this is how we should understand the metaphysics of modality. That the modal facts are facts about possible worlds. I think that they are not. Okay, well, that's everything for this video, and I'll see you next time. Bye, everybody.